Good evening, sir.
So we have to start with lenses. So a lens is a piece of transparent material, okay, through which reflection can occur. So it is bounded by either two spherical surfaces or one spherical surface and other plane surface. And based upon this, there can be different types of lenses. The two bounding surfaces may be both convex or one plane, other convex, or one concave, other convex, or both may be concave. Okay. So first of all, it is convex or converging lens. Convex is thick at the center. These lenses are thick at the center and thin at the edges. So these are of three types. First one, which is much widely used, is double convex lens, or it is also called simply convex lens. Double convex, it is of this kind. Both surfaces are convex. Okay. Second one is plano convex. Means one surface is plane, other is convex, like this. This one. Concavo convex. Concavo convex. So it is like this. Like this. Concavo convex. Is it clear?
Yes, sir.
And similarly, we can have types of okay. So now, similar to the mirror, there are certain things related to the lenses. For example, same principal axis, optical center, principal focus. Okay. So what do you mean by principal axis? It is the line joining the center of curvature and the optical center, we can say. And there will be two centers of curvature. There may be one also in case of concave, but and what is the optical center? This is a point on the lens itself at which if a ray falls, then it goes undeviated. Principal focus, again same. It is a point F on the principal axis where all the parallel rays they meet or appear to come from. Either converge actually in case of convex lens, okay, or appear to diverge from in case of concave lens. I will make the diagram. Please note down.
Yes, sir.
Yes, sir.
it is denoted by f, and the distance OF is called focal length of the lens. Okay. For convex lens, focal length is positive. Okay, and this is called focal length. This is 0.2. In case of concave, what will happen? This is the focal length. Okay. Clear?
Yes, sir.
Next one is aperture. Next one is
Sir,
aperture. Actually, it is the effective diameter of the transmitting portion of the lens. You can say
okay, sir.
this is the portion, the transmitting one. So that diameter. Okay. And aperture decides the brightness of the image, because if the aperture is more, then more light will be able to enter the lens, so the image will be brighter. Okay. And then there is a lens maker's formula. Lens maker's formula. This is the formula which connects the focal length of a lens with refractive index of its material and radii of curvature of two surfaces. Okay, so it is a formula which connects the following assumptions are made while deriving this formula. Of course, we won't be deriving the formula, but you should know the assumptions. The first assumption is the lens is a thin lens, so that the poles P1 and P2, they lie close to the optical center. There are two poles of the lens because there are two surfaces. The second assumption is the aperture is small.
Yes, sir.
Third is the object should be a point object. Let us not write the object is a point object lying on the principal axis of the lens. Nothing is audible. Nothing is audible to me. Only kit. Somebody was able to hear? Then please can tell me.
No,
No,
sir.
sir, same here.
You can type, Durga. Instead of speaking, you can type. Okay, it's okay then. And then there are some sign conventions. Of course, you know about them. So I will be writing in short. Okay. What are the sign conventions? We have already discussed in case of mirrors. The first one, all the distances have to be measured from the optical center. Measured from the optical center in case of lens. And the distance is measured along the direction of incident ray. Okay, so these are the sign conventions. And now what is the lens maker's formula? Can anyone tell me?
1 by f equal to 1 by v minus 1 by u.
1 by f equal to
1 by v minus 1 by u.
that is lens formula. I'm asking about lens makers.
1 by mu minus 1, 1 by r1 minus 1 by r2.
Yeah, this is lens makers formula. Lens makers means it is used by lens manufacturers. Okay, how to carve the lens, how much radii of curvature it should have, and that will decide the focal length of the lens. Na? Okay, clear?
So can I go to previous slide once? Yes, sir.
That is the lens formula that you were talking about. This is lens formula. How the lens works. This is how the lens is made. Okay, both are different. Now let us discuss the image formation by the lenses. Okay. So image formation by convex lens, because there are a number of cases. Concave, just like a mirror, it has only 2 cases. Image formation by convex lens, double convex, if I say exactly. So when the object is at infinity. What will happen when the object is at infinity?
Immediate focus.
This is the focus. Then how the rays they will come?
So if they come parallelly, then it will made at focus. If they come tangentially, then it can made in focal plane.
They can go like this. Like this. Sorry. See. Okay. So image is real. 1 minute. Image is real, and you can see inverted. Obviously, it will be diminished and formed at f. Okay. So now we will bring the object closer to the lens. So between infinity and 2f. Second case is between infinity and 2f. This is 2f. Object lies beyond this. It passes through this focus, and one directly passes through this optical center. Image is real, inverted. Is it smaller or bigger?
Bigger.
Smaller. At 2f, it will be equal in size. Na?
Yes, sir.
Till 2f, it will be smaller. Na? And formed between f and 2f. Actually, my image is not to the scale. Na? I have not taken the focus properly on either side. But if you make it in the copy with the scale and pencil, then you will find it will
Yes,
be
sir, small.
Yes. Otherwise, also I'm drawing all the lines with my hand only. Na? I'm not using the scale. Otherwise, I have to go back into the software every time. Okay. Now, third case is object at 2f. Let me mark. This was f. This was 2f. This is focus. Object. I forgot to number the pages. This was 10th and this is 11th. It appears to be a little bit bigger this time. Na?
सर इसमें सेम साइज.
Yes. You can see all the time image is real inverted. But as the object is coming near to the lens, the image is going away from the lens. Na? Now it is bigger in size. And it will be beyond 2f, you can see. It is very difficult to make the diagram. Image is real, inverted, enlarged, formed between 2f and infinity. Please note down. Clear?
Yes, sir.
Yes, sir.
Rays are parallel. Na? So obviously they will meet at infinity. Na?
Yes, sir.
So image is real, inverted, enlarged, formed at infinity. Okay. Clear?
Yes, sir.
Object between f and optical center.
सर इसमें बच्चे बनी.
Yes. Your convex lens, actually it is similar to concave mirror.
Yes, sir. Opposite.
And concave lens, it is similar to convex mirror. That's what you can remember. It's like this. Virtual, direct, enlarged, and formed between infinity and 2f. Na? And on the same side as that of the object.
सर मेरा तो FN 12 के बीच बनना.
आपका between f and 2f बन रहा है?
Yes, sir.
Possibly नहीं मेरे हिसाब से.
उसे ड्राइंग गलत हो गया.
Yes, sir. Yes, sir. Drawing.
It will always be beyond 2f.
Okay, sir.
Let me think 1 minute. Yeah, it will be beyond 2f because at f it was at infinity. Na? Image दोबारा.
This according to lens formula. Or
Yes,
the
obviously. Are you getting it beyond 2f now? Or still between f and 2f?
Sir FN 12.
have you marked the points F and 2F with proper measurement or on both sides of the lens?
No, sir.
Then what is the use?
Yes, sir. With
Suppose you are taking this as 3 centimeter. This will also be 3. This will also be 3. Only then you can say.
yes, sir.
Otherwise, it is wrong.
Okay.
So image formation by concave lens. Object at infinity. Here is the image. This is the focus. This is the optical center. So image is virtual. You can see erect, diminished, formed at F. Second case, object is in front of the lens anywhere. One minute. Yes.
Okay.
So image is virtual. You can see erect, diminished, and formed between F and optical center. No? Okay. Please check. Now let us discuss something about magnification. Again, linear magnification. Okay, it is defined as the ratio of the size of the image denoted by M, and image all the time we have been taking as A dash B dash and object as AB. In case of real and inverted image, magnification is negative, and in case of virtual and erect image, magnification is positive. Okay, and M is V by U for all the cases. So V and U accordingly follow, and this is the general rule that is applicable. Okay, clear?
Yes, sir.
And now we define the power of a lens. How powerful the lens is means, suppose we have two convex lens, which lens is more capable of converging more number of rays to a single point, and it is defined as a reciprocal of focal length in meter, and the units of power are diopter. And how do you define one diopter? When the focal length is 1 meter, no?
Yes, sir.
Or 100 centimeter. So now, according to lens maker's formula, we have this now. So we can actually replace this 1 by f by power now. Please check. And of course, if focal length is positive, power is positive. If focal length is negative, power is negative. So it means it is positive for convex lens and negative for concave lens. Okay. Here.
So any short form of diopter?
Short form of diopter.
DPT, something.
Yeah, you can write that. Capital D. DP simply. Now, what happens if we have more than one lens in combination? Suppose two lenses are there. Suppose both are convex like this. One is this. Okay. So focal length of one is f1, other is f2. So in this case, the combined focal length.
1 upon f1 plus 1 upon.
Yes. Here f is the combined focal length of the combination, or the focal length of the combination. So it means P will be P1 plus P2 because 1 over f is P1. So it means the power of the combination is the sum of the powers of individual lenses. Is it clear?
Yes, sir.
Let us discuss some problems. So this is the combination of lenses, and the focal length of these lenses are. This is the diagram. So you have to solve this question one by one. Samudra, this is the final answer you are giving me? Yes, this is correct. So we can make use of lens formula to get V, and I will be calling that as V1, okay? This is U1 F1. Please substitute the values and get V1. No, Mira. This is the first answer or final? If this is the first one, then it is correct. Yes, Rita. First one, it is correct. Okay. Now this V1 will act like an object for the second lens, and it is coming out to be 15. Na? It means the image will be here. First image, that is this V1, and this is 10 then, because this is 5, so this will be 10. Na?
The second
It means U2 will be plus 10. Na? U2. This will be U2. Na? Am I right? So V2, 1 by V2 will be 0. Na? It means V2 is infinity. It means for this third lens, the object is at infinity. Am I right? And we know that when the object is at infinity, the image is formed at focus, and the focal length is 30 centimeter. Okay. Is it clear? So for the third lens, otherwise also you can get it mathematically, because V2 is coming out to be infinity, so will be U3. Okay. So now you can put these values in the formula. Otherwise also theoretically we are getting the same thing. So it means the final image is formed at 30 centimeters to the right of third lens. This here. The final image will be formed here. So this is what we have to calculate. Now. Please check. Is it clear?
previous slide.
Yes.
Sir, diagram वाला.
एक्चुअली ये नीचे बनेगा, अगर आप बनाना चाहते हैं, एक्चुअल में बनाना चाहते हैं तो इट विल बी डाउनवर्ड, और रियल बनता है ना.
सर V1 15 आ रहा ना, तो सेकंड कॉन्वेक्स लेंस के पास बनेगी.
ओके, आई डिडंट नोटिस एक्चुअली दैट. तो हाँ, यहाँ पे ही बन जाएगी.
यस सर.
यहाँ पे बन जाएगी, तो यू आर राइट 15. तो इसके लिए दिस विल बी 10 ना. सी,
यस सर. यस सर.
मैंने वो देखा ही नहीं कि वो 10 है, मैंने 5 देख करके बना दिया. थैंक यू. नेक्स्ट वन.
सर वन डाउट.
यस यस.
सर U2 -10.
हाँ यस. प्लस 10 माइनस 10 कैसे? इसके राइट पे है ना. दिस वन इज टू द राइट ऑफ कॉनकेव ना. लेफ्ट पे इट इज नेगेटिव, राइट पे इट इज पॉजिटिव. सो ये अब प्लस 10 होगा ना, राइट पे है 10 सेंटीमीटर.
ओके ओके सर.
Distances to the right are taken as positive and to the left they are taken as negative. Let me help you with the diagram. Okay, so it is given that a needle 10 centimeter long is placed along the axis of a convex lens. Its middle point is at A. Okay, तो मतलब 2F पे आया ना middle point.
Yes sir.
So here is the needle. So needle ये 10 centimeter है, तो this is 5 centimeter to the left and 5 centimeter to the right of 2F ना. Let's call it AB. अब इसकी इमेज कहाँ बन रही है वो हम निकाल लेते हैं. तो obviously मिडल पॉइंट तो C पे ही रहेगा ना, मतलब 2F पे.
Yes sir.
It will get elongated ना. तो एक्चुअली क्या होता है, ये वाला इस वाले का उस तरफ बनेगा दूर, इस वाले का दूर बनेगा, इस वाले का पास बनेगा ना. तो वो हमें देखना होगा. तो अभी के लिए लेट मी मेक समवट बिगर ऑफ कोर्स. तो B डैश A डैश. ओके, सो देखें क्या बन रहा है. तो एक्चुअली वी विल टेक द मिडल पॉइंट. दिस इज द मिडल पॉइंट, सो वी हैव टू सी द इमेज ऑफ पॉइंट A. सो दिस विल बी 15 ना.
Yes sir.
And for B it will be 25 then. So what you have to do is you will get the image position for A and B, and then you can decide the length by getting the difference between them. Okay, you will get the position of the image for A and B, and then you have to get the difference between them. That's what you can do. Okay, clear or not?
Yes, sir.
Yes, sir.
So for and A, what was U? Minus 15. Can I call it U1? F is 10. So A ka image. So this one is plus 30. Okay. So for and B, U2, it was minus 25.
Yes, sir.
How much?
16.66.
16.66.
7. So if we mark in the diagram, so now we can get the difference to get the length of the image needle. 30 minus this. So therefore length of 13.33 in fact.
Yes, sir. 3.4. 3.
Okay. Clear?
Yes, sir. Please solve this. So you can actually make use of lens maker's formula because mu is given, radii of curvature is given. Because for this face, see, this face the radius is positive, for this face the radius will be negative. It will be towards left. Okay.
Yes, sir.
What is this value? 17.6.
86.
So now the height of the object is given, U is given, so we have to get V. U is given, F is known, then what is the use of this?
Yes, sir. That is I am also thinking.
Okay, we will also get the size then, but they are not asking for it. No? So no use of that information. Please solve this. How much? Minus. So I will be 22.73. So it is positive. It means the image is virtual and erect. and because magnification is coming out to be more than 1, so and enlarge. Okay. Done.
Yes, sir.
Sir, one more.
Okay.
Okay, sir.
Please try to solve this. When the lens is in air, refractive index will be a mu g. So we can get the value of this 1 by r1 minus 1 by r2. So now we can use this information. But no, Durga, it's not the correct one. Now the lens is in water, na? So it will be W mu g. You might not have taken care of that. For air, you are taking it to be A mu g. Na? When the lens is in water, it will be W mu g. Na?
Yes, sir.
Have you
I
taken
take
care of that?
I take A water.
That will be wrong. Na? How can you take air water? Lens is made up of glass. Na?
Yes, sir. Earlier referred to.
Yes. So now we can directly put its value. Na? 1 by r1 minus 1 by r2. So this is mu g by mu w. Na? And this is 1 by 10 na? From 1. So mu glass. It is 1.5 and then it is 1.33. How much? So this is the final answer. Okay. So tomorrow again we will discuss problems on lenses and of course combination of lenses. Okay. So that's all for today. Okay, students. Bye bye. Take care.
Thank you, sir.
Thank you, sir.